Hi, what we're going to do in this lesson is look at some of the techniques that geologists use for dating different types of rock. There's a few key principles that we use to establish the relative age of one rock to another, whether one rock's older or younger than another one. And we can illustrate these ideas by looking at some of the features that we can find in and around school. So we're going to look at for a few of these places and see what they can tell us. The first place we're going to go is B block. Let's go and have a look. Okay, the first site we've come to look at is the wall of B block. Now, if we look at this wall here, we can see that there are different layers within the bricks. Now, what I'm about to say is perhaps really obvious, but it's the important first principle we use in dating rocks. If you look at this layer of bricks down at the bottom of the wall, this layer of bricks must have been put down, they must have been put in place before this layer. Similarly, this layer has to have been laid down before this layer of bricks. And finally, of course, the layer we can see up there must have been the last of these four to be put in place. So therefore, this layer at the bottom must be the oldest. The one near the top must be the youngest in the sequence of brick layers. Geologists call this the principle of superposition. And as long as a set of beds are the right way up, the oldest one must be at the bottom, the youngest one must be at the top. So we can always establish the relative age. This layer is younger than this layer. This layer is older than this layer. It's the first and most basic of our principles. Once we've got that established, we can start thinking about some other ways to work out the relative age of the rocks. The second place I want to take you to is the wall of the canteen. So let's go there now, shall we? Okay, we've now come to the wall of the canteen. And the reason we've come here is to look at the concrete slabs that make up this wall. Let's have a close look at what these slabs are made of. If you look carefully, you can see that these concrete slabs are made up of fragments of rock. These look actually like rounded quartz pebbles. They're held up then in a matrix of sand and cement. So these are, I suppose, a human-made equivalent of a sedimentary rock, maybe a breccia or a conglomerate. Now the reason we're looking at this is to see, again, the relative age. When this concrete slab was made, all these pebbles must have existed to be made into part of this concrete slab. So therefore, these pebbles must be older than the slab that we now find them in. Now, geologists call this idea the law of included fragments. It means that the fragments that we find within a sedimentary rock must be of a pre-existing rock, one that's older than the rock that we now find them in, because it must have existed to be eroded, to make a clast, to be redeposited into a newer sedimentary rock. We can find this particularly where we have unconformities, where we have erosive surfaces in the geological record. Okay, the next place I want to take you is over to the Mugger pitches. Let's go over there now, shall we? Okay, let's look at our last principle of dating. This is what we call the law of cross-cutting relationships. Now, if you look it up in a geology textbook, it says that if one geological body cuts across another one, it must be younger than the body it's cutting across. Sounds a little bit complicated, but if we look at some of the lines that we can see here on the sports pitch, we can illustrate the idea really very clearly. Let's have a look at this area down here. You can see that we have three different colours of lines painted on the tarmac. We've got yellow, we've got white, and we've got blue. Now I can see, looking here, this yellow line cuts across both the white and the blue lines. That tells me that this yellow line must have been painted after the white and the blue lines. It's younger than both of those lines. We still, though, don't know whether the white or the blue line which is the older, which is the younger. So for that, we need to look at another place on this pitch. There's one just over here. Here we can see a cross-cutting relationship between the blue and the white line. I can see here that the blue line cuts across the white line. So that tells me that the blue line must be younger than the white line. So we can now establish the order in which these lines were painted on this pitch. The first one to be painted was the white line. The other two lines cut across it. The second one must be the blue line. The blue line's younger than the white line because the blue line cuts through the white line, but the blue line, as we've seen, is cut by the yellow line. So the yellow line must be the youngest. We can apply this idea in lots of different geological ways, particularly when we start looking at igneous intrusions, unconformities, and faults. That's our three techniques. We'll go somewhere else and we'll have a think about what this means in terms of the geology. Let's go now. Okay, so let's have a think about what we've seen. If we apply these ideas of superposition, included fragments, cross-cutting relationships, it's possible to look at an outcrop of rock and work out the age of all the rocks within that outcrop relative to one another. So we can start to work out the geological history. We can also apply some other knowledge that we get, perhaps by finding fossils within the rock, perhaps even by being able to put a radioactive date on any of the rocks that we can find, particularly igneous rocks. We can date in that way. All this information, though, we can piece together to come up with a geological history, to start to establish the story of the geology in any one place. We need to have a look at how we actually apply this in geological terms, but that's perhaps for another lesson.